Hello everyone, in this lecture I am going to discuss about the DAT11 sensor interfacing with the Arduino. Basically DAT11 sensor measure the humidity of the surrounding air as well as temperature. So it is only one sensor but it can measure two parameters, humidity and temperature. So first let us start with the topics that I am going to cover in this lecture. The first one is a hardware and software requirement. The second one is a DAT11 sensor working principle. What is the construction of DAT11 sensor? How it measure the humidity and temperature. Then how we can connect the DAT11 sensor with the Arduino. That is a DAT11 sensor connection with the Arduino board. Then Arduino code. I will explain the Arduino code for the same and Proteus design. And the final one is a video of actual hardware implementation. So these are the topics that I am going to cover in this video lecture. So first, let us start with the hardware and software requirement. Okay, you require one Arduino board. I have used the Arduino Uno board. You can also use the Arduino Nano. Then DAT11 sensor which measure the humidity as well as temperature. Then jumper wires which is used to connect the DAT11 sensor with the Arduino. Then USB cable for uploading the program from PC or laptop to the Arduino board. And the final one, you require a software, that is Arduino IDE, for writing the Arduino code. So these are the requirement of hardware and software for interconnection of DAT11 sensor with the Arduino board. Now let us start with the first thing, that is DAT11 sensor. So basically DAT11 sensor, it is a low cost digital temperature and humidity sensor. For measuring the humidity, it uses the capacitive humidity sensor, and for measuring the temperature, it has thermistor. So it measures the surrounding air humidity as well as temperature. Okay, it can measure the relative humidity in percentage. The range is in between 20 to 80% RH, that is the relative humidity, and temperature in terms of degrees Celsius in between range of 0 to 50 degrees Celsius. Okay, what is there is a plus or minus 5% accuracy if in the case of humidity, and plus or minus 2 degree variation is there in case of temperature. DAT11 sensor only use one wire to transmit the data to the Arduino. Though it is measuring two quantity, but only one wire is there. Okay, so those quantity will be measured. Humidity and temperature will be measured by humidity sensor and thermistor. Then it will be processed, okay, by the IC which is there in this module, DAT11 sensor module, and then that data will be sent to the Arduino board. Okay, now there is another sensor, that is a DAT22 sensor. DAT22 sensor is having higher range in, as compared to the DAT11 in terms of humidity as well as temperature. Compared to the DAT22 sensor, the DAT11 sensor is a less precise, less accurate, works in a smaller range, that is in terms of temperature and humidity, but it is a smaller and less expensive. This is only one advantage. So as compared to DAT22, okay, this sensor is less precise, less accurate, and it measure the range is also less as compared to the DAT22 sensor. Now, how DAT11 sensor measure the humidity? So this is the construction. You can see what it consists of. So there is a humidity sensing component along with the thermistor. Okay, humidity sensing component has a two electrode. You can see this is a upper electrode and this is a lower electrode, and in between there is a moisture holding substrate is there, which is sandwiched in between these two electrode, and this final all these three will be placed on a glass substrate. Okay, the DAT11 detects the water vapor by measuring the electric resistance between the two electrodes. Okay, so it measures the amount of water content in the air, and the humidity sensing component is moisture holding substrate as I mentioned, and which is connected with the electrode. You can see with the electrode applied to the surface. Okay, when water vapor is absorbed by this substrate, this moisture holding substrate, then ions will be released. Okay, ions will be released by this substrate, which increases the conductivity between two electrodes. Okay, so there is a two electrodes are there in between, this moisture holding substrate is there. When it absorbs the water, then it will release the ion, and it will release the ion, then conductivity between these two electrodes will increase. Okay, the change in conductivity increase, ultimately resistance will change. So change in resistance between two electrodes is proportional to the relative humidity. Okay, higher the relative humidity, decreases the resistance between two electrodes. Okay, and if relative humidity is low, then resistance between two electrodes is high, and based on that output signal will be generated. Okay, now how it measure the temperature? So for temperature, it is also having one thing, that is an NTC thermistor. Okay, DAT11 also consists of NTC or thermistor to measure the temperature. Now what is NTC? NTC is a negative temperature coefficient of resistor. Okay, a thermistor is a thermal resistance whose resistance changes with the temperature. The term NTC means what? As I mentioned, negative temperature coefficient. What does it mean? It means that resistance decreases with increasing the temperature. So here this is a graph of for NTC, with the graph of resistance versus temperature. You can say as the temperature increases, resistance decreases, and resistance decreases, based on that output will be generated. So this is how DAT11 sensor measure the humidity as well as temperature. The next one is a DAT11 sensor pin diagram. So this is a sensor module you can see, okay, which consists of 3 pin. It is also available in the 4 pin. Okay, the leftmost pin, that is a VCC, okay, where we are connecting the 5-volt supply for giving the supply to the sensor module. Okay, middle pin is the output pin from where we are getting the data, and that this pin is connected to the Arduino board, one of the pin of the Arduino. So these are digital sensors, so we will use the one of the digital pin of the Arduino. So this pin will be connected with the one of the digital pin of the Arduino, and third pin is a ground pin. Okay, which is basically connected to the ground of the Arduino. The second pin is used to make communication between the sensor and Arduino. Now, which are the application of DAT11 sensor, where it is used? So there are many applications. So first one is a HVAC, that is it is using heating, ventilation, is air conditioning system, where these three things will be there. We can use DAT11 sensor. Then weather station. In weather station, these are the two important parameters, humidity and temperature. Okay, so it can be used over there. Then medical equipment for measuring the humidity. And home automation system, it can be also used if you want to measure the temperature of particular room, okay, as well as humidity inside the home. So we can use the DAT11 sensor, and it is also used in automotive and other weather control applications. So these are the few applications which I have covered. Okay, now DAT11 sensor interfacing with the Arduino. So here you can see this is a DAT11 sensor. Okay, pin diagram we have already discussed. Okay, so the leftmost pin is a red color wire which is connected to the 5-volt of the Arduino board. You can say Arduino Uno board. Okay, then middle pin is the output pin. Okay, that is a green wire. You can see this is connected with the 9-number pin of the Arduino board. Okay, and the final pin is a ground pin, and which is connected with the ground of the Arduino via this black color wire. So this is how you can connect the DAT11 sensor with the Arduino. Okay, and I have used the 9-number pin. You can use any pin. Okay, the next one is a Proteus simulation. Okay, so in Proteus we can simulate and we can get the output. Okay, so here DAT11 library you require. If it is not there, okay, you have to find and you have to place in the labs library folder of the lab center, which is in the C drive. Okay, basically it consists of 3 pins. Okay, VDD, that is connected to the plus 5 or plus 10 volt in between. Okay, then the next pin is a data pin. Okay, which is connected to the 9-number pin, and the third pin is a ground pin. Okay, it can show the value of both humidity and temperature. Okay, and here one virtual terminal is also there, which is basically used to display the data. Okay, final data, measured data. So this is how you can simulate the DAT11 sensor interfacing with the Arduino. Now between VDD and data pin you have to connect one register. Okay, R1 register. Okay, now let us see the Arduino code for interfacing of DAT11 sensor with the Arduino. So this is the Arduino IDE sketch. The program which I have used, I have already written, you can see. But whenever we are using the DAT11 sensor, we require the DAT11 sensor library in the Arduino IDE. Okay, so you have to add that library. You have to find that library and you have to add. You can see here, add library is there. So where you can download it from, you can do it Google. Okay, you can easily find out. You can easily find the DAT11 library, and then use this option, that is add file. Okay, and give the path where you have downloaded that library. Okay, then and then this program will run, otherwise it will not run. Okay, so first thing you have to mention is that has include in bracket dat.h. Okay, so that library we have included. Then out is a one variable, and that pin 9 number is given the name out. Okay, so with this dat11 sensor, with we will be connected to the 9 number pin of the Arduino. Okay, defines the pin number to which the sensor is connected. Then DFT space capital DFT. So this is the one line you have to write. It will create the DFT object. Okay, so this is a must requirement. Okay, then there are two loops: a void loop, void setup, and void loop. So in void setup, okay, serial dot begin in bracket 9600. That is a baud rate. Why I have used? Okay, I have already explained this in the previous video. Serial dot begin basically whenever we want to display the data, final data on serial monitor, then we can use this one. Okay, then void loop. Okay, in void loop one variable I have defined, read data, that is integer. Read data is equal to dat.read11. Okay, so this is one of the inbuilt function of the dat.h library. Okay, out. So what is out? Out is a 9 number pin. So what it will do, it will read the data of 9 number pin. Then float h. H is for humidity. H is equal to dat.humidity. That is another function which is part of this library. Okay, so dat.humidity, it will read the humidity of the surrounding air. It will give the value of that. And then another is a float T is equal to dat.temperature. It will read the temperature. Okay, now this data you can display on the LCD as well as you can show this data on the serial monitor. So I have used the serial monitor. So serial.print command I will use in bracket quotation mark temperature. So temperature is equal to will be displayed on serial monitor. Then serial.print T. T is what? The value of temperature. That value will be displayed. Okay. Then serial.print in bracket degree Celsius and in Fahrenheit is equal to. Okay. So this line will be displayed on a serial monitor. Then serial.print in bracket. Now this degree Celsius value is converted into the Fahrenheit. So this is an equation. Okay, T into 9 by 5 plus 32. So this will convert the Celsius into a Fahrenheit, and that value will be displayed after this line is equal to. Okay, then serial.print lnf. Okay, so that the value is represented in terms of Fahrenheit. Okay, then serial.print. Now serial.print ln is there. Okay, so that means after that new line will come. Now next is the serial.print humidity. Okay, in quotation marks. So humidity is equal to will be displayed in the next line. Then serial.print in bracket h. So a value of h will be displayed after this humidity is equal to. Okay, then serial.print ln. So percentage will be displayed, and then after delay of 3000 millisecond is given. So for 3 seconds program will not run. So after every 3 seconds the data will be updated on a serial monitor. Okay, this program I have successfully run. You can see here done compiling. Okay, and this is a hex path. Okay, which we are using for Proteus simulation. So this is a Proteus simulation circuit. You can double click on this. In Proteus design, you have to double click on Arduino board and you have to provide that path. So ultimately, those measured data will be displayed on a virtual terminal. If you will increase this value, so that value will be updated in the virtual terminal. Okay. Now let us see the video of actual hardware implementation.
Now let us see which are the components required. So first one is a Arduino Uno board. Then next one is a USB cable for uploading the program in the Arduino Uno. Then this is the DHT11 sensor. You can see, okay, it consists of 3 pins, okay, and middle pin is a output pin. This is a DHT11 sensor, and the final one is a jumper wire. So these are the components required. So now let us see the connection of DHT11, that is a humidity and temperature sensor with the Arduino board. Okay, so this is the humidity and temperature sensor DHT11. Okay, middle pin is the output pin, and it is connected with the 9 number pin of the Arduino. You can see Arduino Uno, and other 2 pins are VCC and ground pin. Okay, now it is program is already loaded. Okay, now let us see what is the output. So here you can see serial monitor is open, and you can see the temperature is 29 degrees Celsius, and it is also shown in terms of Fahrenheit, and humidity of the room is around 43%. Okay. Now you can see heating iron is placed near the DAT11 sensor. Okay, and what will be the effect of this on the temperature? So let us see. Now you can see temperature is increasing from 29 degrees Celsius to 31 degrees Celsius, 32 degrees Celsius. Okay, and there is also change in the humidity also. Now if heating iron is removed, okay, now let us see what is the effect. So now we can see the temperature is decreased. Okay. So this is how we can measure the humidity and temperature with the help of DHT11 sensor and Arduino Uno.
So that's it for this video lecture. In this video lecture, I have discussed how we can measure the temperature and humidity with the help of DHT11 sensor. Hope you enjoy the video. See you soon in the next video. Thank you for watching.